In this video, I'm going to talk about light rays, reflection and refraction. A few important points we need to know before going to the light. Light waves are nothing but electromagnetic waves, EM waves. Okay, they travel in straight line paths called light rays. Light rays can cross without interacting with each other, and some material reflect the light, some materials let the light pass through them. That's called refraction. Reflection is nothing but some material do not allow the light passing through them, so it reflects the light back. So all the metals, they reflect the light. Now I'm going to talk about law of reflection. So we're going to do many examples based on this law of reflection. So in the law of reflection, we need to know two angles. One is called theta I. Theta I is called angle of incident. Okay, what is the angle that light ray falling onto the object with respect to the normal? And theta R is called angle of reflection. Theta R called angle of reflection. Now, if a light ray fall onto this object, assuming this is an object, okay, here is the normal. Normal is a perpendicular line to that object. This object is, on the x-axis. Assume that it's on the x-axis. Now, if a light ray falls onto it, okay, with an angle of theta I, the theta I is angle between the light ray and the normal. This is the normal. Normal is nothing but a line perpendicular to the object. So if a light ray falls onto it with an angle of incident theta I, now that is going to reflect with the same angle that that angle is called theta R. But according to law of reflection, okay, according to law of reflection, theta I equal to theta R. This is very important point you need to remember. Okay, according to law of reflection, theta I equal to theta R. Theta I is nothing but angle of incident. Theta R is nothing but angle of reflection. So if a light ray falls onto the metal or any material, when it reflects, the angle of incident is equal to angle of reflection. Now here I'm going to solve an example based on the law of reflection. As I mentioned, you must know theta I equal to theta R, where theta is angle of incident, the angle between the object and normal. Normal is always perpendicular line to the object. Assume that the object is lying on the ground, which is parallel to the x-axis. Normal is always parallel to the y-axis. Now here is a first example. There are two flat mirrors are perpendicular to each other. So there are two mirrors. The two mirrors are perpendicular to each other. So the first mirror, I'm assuming it is on the x-axis, and the second mirror I'm assuming on the y-axis. They are perpendicular to each other at the same time. They are assumed that they are touching at the origin. Now, an incoming beam of light makes an angle of 15 degrees with the first mirror. So he mentioned, and clearly he gave us the diagram where he mentioned the light ray is falling onto it, is making an angle of 15 degrees with respect to the normal. Okay, what angle will the outgoing beam makes with the second mirror? So what is the angle of reflection? That's what he's asking about. So here the given information is, all we know is angle of incident. Theta I is given, which is 15 degrees. So theta I equal to 15 degrees. Now what happened to this light? This light is going to reflect. So when it reflected, it's going to reflect it onto the second mirror, because we know that theta I equal to theta R according to the law of reflection. So theta R must be here, which is going to be 15 degrees. So if this is 15 degrees, we know that this angle must be 75 here, and then the remaining this angle must be 15 degrees there. Now I'm going to draw a normal to the y-axis. Okay, this now this ray is incidenting on the second mirror, means falling on the second mirror. So theta I here must be equal to 75 degrees. Okay, what will be the theta r? Now theta r is going to be 75 degrees. Okay, with the second mirror. So the final angle must be you can say theta r, which is 75 degrees, but the question he's asking about, what is the angle, what angle will the outgoing beam makes with the second mirror. So he's talking about what is the angle right here. Okay, with the beam, this is the beam with the mirror, so this must be 15 degrees right there. Now I'm going to make or do the similar example. Here the two mirrors, they are not perpendicular to each other, but one mirror is lying on the x-axis. So here is example 2 we're doing. Another mirror is making some angle with that first mirror. The angle between those two mirrors are given, which is 130 degrees. That is already given. Now I'm sorry, actually in the question the angle between those two mirrors are given as 135, not 130 as I mentioned. The angle between those two mirrors are 135 degrees. 135 degrees. Now if the light ray strikes on the mirror which is parallel to the x-axis at an angle of 38 degrees, what is the reflected angle, the final reflected angle? Final ray reflected angle. So here the light ray is striking the first mirror. He didn't say that is an angle of incident. At the same time, this diagram is given with the question. So this is not theta I, but this light ray is making around 38 degrees angle with the mirror, not with the normal. So here is the normal, the red line is the normal, and the orange line is the light ray. So when the light ray falls on it, what happens? It will reflect. Now can we find the theta I? The theta I must be, we know that normal and mirror, they are making 90 degrees. So theta I must be 90 minus 38 degrees. So that must be 52 degrees. So the angle of incident is 52 degrees. Now what happens to the light ray? Light ray is going to reflect. We know the angle. That angle must be 52 degrees right there. Now what is the outgoing angle of that light ray with the second mirror? That's the given question. So I'm going to draw the second line or normal with the second mirror. Now can we find theta I with the second mirror? Now we're going to find that. Look at this. Here I see a triangle. The triangle is like we have 135 degrees between the mirrors. That's the angle given between the mirrors, and the light ray is making an angle of, so this angle must be 52 minus 90, so this angle must be 32 degrees right there. 38 degrees, sorry, 38 degrees. How did I know that? Because we know that this normal is 90 degrees to the mirror, and we know the angle between the normal and the light ray. So that's why I got 38 degrees. So now what is the angle here at the third corner of the triangle, which is 180 minus 135 minus 38 degrees. That will give me the angle between the second mirror and the light ray. That angle is 7 degrees. Okay. 135 minus 35, which is 173. So 135 minus plus 38, which is 173. 180 minus 173 will give me 7 degrees. So the angle here must be 7 degrees. Okay, now what is the angle of incident with the second mirror? Angle of incident with the second mirror must be, we know this angle must be 90 degrees. Out of 97 is gone, so it must be 90 minus 7, which is 83 degrees. Okay, now the light ray, we know that angle of incident is 83. Now according to this law of reflection, okay, according to the law of reflection, theta I equal to theta r. So here theta r is also 83 degrees. Once I know theta r, what is the angle it is making with the reflected, with the second mirror? That's not exactly reflected angle, it is the angle between the second mirror and the light ray. So that must be 7 degrees, because if theta r equal to 83 degrees, if theta r equal to 83 degrees, I know that the angle between the normal and the mirror must be 90 degrees. Out of 90, 83 is gone, so you will end up with 7 degrees. That 7 degrees is the angle between the reflected light ray and the second mirror. I'll stop this video here. In the next video I will solve more examples. Thank you.